Hello everybody and welcome back to my bench. Well, today I have again a very nice repair video for you. So as I know that is what you all like. And today I have here a very nice ICOM. It is a IC-706 MKIIG. So that is the latest version which was on the market before we got the new system, the new radio IC-7000. This is really a very wide distributed radio, and everybody are still using this radio, so yeah, it is really worth to repair. But today, yeah, you know, it is really a little challenge, because this radio came in and somebody else has already tried to repair it, and so I received it. Let me see if you can see it. So one of the antenna jacks has been taken out, and well, I got a bag of you know, dismantled parts, and so I do not really know what really has happened to this radio. So what I know is it worked as remote station, and well, then suddenly there was a problem with transmit, and the radio failed. So we definitely have a transmitter problem. And well, with the radio as well came a copy of the, so that is a part of the final stage. And well, there is a transistor marked here in this copy, and that is a pre-driver. So I don't know if this transistor was already located or identified as failed, so I do not have a clue. So, you know, normally you do not really like to repair a radio where somebody else has already started a repair, because that can become a nightmare. But you know, this radio is from a good friend of mine, and so I will see what we can do, and so yeah, we will try to get it fixed. And as my friend Paul from Mr. Carlson's lab always says, sit back and relax and follow me along this repair. So okay, let's open the radio and see if it becomes a nightmare or not. So radio is not closed with all the screws, so there are only two which we have to open, because as I said, yeah, somebody else was in before. And let's see. Okay, so here this side is not really touched, so that seems to be basically okay. And then let us see what we have here. And therefore again this both screws, and okay, so here it looks a bit different, so you really can see that somebody was already in, so a lot of open connections which has not been put back in the position, and let me see what we have else. And okay, so let me see if you can maybe see it. So let me see. No, that's too close. And now, yeah, it is zooming in. Okay, you may see it down here. So yeah, it looks like that a part has been taken out, and it may be that it is a pre-driver which was marked in the copy of the schematic which I've shown you. So maybe that here is the position where the problem may be. So we need to investigate this area a little more in depth, and yeah, then we may see a bit more. Yeah, if we look down here onto the PCB, we can see that all screws are out. So that means also the ribbon cable here. So everything is out, and that means that this circuit board was out. And yeah, you can see how easy I can take it. I can take it out of the chassis, and yeah, so you can see how it looks like on this side. So this is a resistor which has a connection to the chassis to cool it a bit better, so they can choose a smaller version, because as you see here we have grease, and there is a direct connection to the chassis. So that is where this resistor is connected to. And well, now what we have to do is to investigate this area a little more in depth, because before we can give some voltage onto the radio to see if the radio will receive, at least, because we do not know nothing, we need to investigate this area. And it really looks like, I don't know if you can see it, but here on this component there are also burn marks, and yeah, this are burn marks as well. So something really bad happened to this area, and yeah, so let me see what I can find, and then we decide how to proceed. Okay, if we look here onto the layout, we find here our Q21, and the Q21 is a pre-driver which is or was marked on the copy I got with the radio. And yeah, you see it is a SMD transistor, and it sits like this. So yeah, you may imagine how it should look like onto the PCB. And well, let's now have a look onto the PCB. Okay, so that is now the PCB view, and well, the only thing I can say is the nightmare starts, because this here is of course the area where the SMD transistor should sit, and well, the most problematic issue right here is that the pads are missing. You see there's only the pad in the middle, but the right pad and the left pad is gone. And well, the problem is this is minimum a double-side PCB. So on two sides, when I flip it over, you can easily see that we have a double-side PCB, and maybe there is also a layer in between. I don't know yet, because if there is a layer in between, then yeah, the problem is that the layer in between can be broken as well, so that connection is then missing, and that would mean this radio is lost, but I do not know yet. But clear is, yeah, you see that is the opposite side, so I've flipped it over, and what you can see here as well, we have brunt marks as well, and here down here is also a little part of this copper missing, and well, you know, that could be the connection with is going through the PCB. So yeah, that is really a problem. And yeah, well, back to the other side. This copper here is loose, so it is not. It has not anymore a good connection to the basic material, so that is a problem. And yeah, this transistor here has clearly burning marks as well. When we look onto our PCB plan, we find that this resistor is the it is the R25, and the R25 is directly connected to this little pre-driver, and yeah, so next will be to check out if we can measure this resistor, but it looks dead because we have burning marks here. Okay, so that is Q21, and it's a Q121, and it is a guy which burned completely out. And down here, let me see, down here we have our, here it is, here is our R125, so that is a guy which has burning marks as well. And yeah, you can see that it is here really directly connected to our MOSFET transistor, and well, if for instance this transistor has really a short, then of course the complete current will go through this resistor, and that could be the reason why we have burning marks as well. And well, as we have seen it here on, let me see if we can see it. Yeah, looks good. So this is our R 125. Okay, and what you see here is this connection of the transistor will finally end here on oops, no, will it work? So it is really so it should work. Yeah, you see that the copper is ending here on this side of the PCB, so that means there is a connection through the PCB to the other side, and maybe another layer in between, what we don't know yet. And the same is here with the right side of this transistor. So this copper is ending as well, and this both copper leads are completely missing. So yeah, so that both leads are burnt off, and so we even do not have the connection to the other side of the board, and maybe to the layer which might be in between, which I don't know right yet, but normally it is only two sides, so normally there is not consequently a layer in the middle, but we will check it out in a second. But now first we will check this resistor to see if this resistor still is okay, or if it is dead. Well, if we look here into the schematic, we find the R125 with 5.6K, which looks a little bit unusual to me, because well, we have to double check it with the spare part list. But when we go back to our circuit, so when we go back here to our circuit and I go down and probe this resistor, you see that we read, yeah, approximately 5.7 ohm and not 5.7K. So it seems that maybe the resistor is still okay, because if this resistor would have been burned out, then we would not read 5.7 ohm, so that would be a little yeah, you know, it I wonder if that would really work, if it would have been burned out completely. So yeah, so maybe 5.6K, which is indicated in the schematic, is not the right value, because for me it looks like that this resistor is good. Also, we clearly see burning marks. I mean, okay, if for a longer period of time a lot of current drained through this resistor, so that might be that it starts to getting hot, and maybe this resistor was close to die, but finally the transistor died earlier. So that could be really okay. I will now double check with the spare part list. Yeah, my guess seems to be right, because here we have the R125, and you see it is really a 5.6 ohm and not a kilo ohm. So that was my impression when I've seen 5.6K in a circuit like this pre-driver is. So 5.6 ohm is right, and we are measuring 5.6 ohm. So this resistor survived. So we really have only a burnt transistor, and now we need to check if the connection through the board are still usable, finally usable, to get right and solid connections. Well, that is now how the MOSFET sits here in the circuit. So that is drain, source and gate. And what we need to know is how it looks like in reality, and therefore we will have a look in here, and that is a component, and we see gate left, source in the middle, and drain on the right hand side. So what we need to find now is the components which are connected with the gate and the drain. And when we have a look on the other side of the board, so that means when we flip it over, then let me see that you really can see it. So what we need to find is, for instance, here the C121, because that is directly connected to the gate, as well as the R121, which is this guy over here, and also very close and connected to the gate is the C121. 21 and 25, sorry. So the 25, which is this, the C121, and the R121. And when we look down here, we see something looks like a pad, and I think this is the connection through the board. And yeah, let's see it on our circuit board. Okay, so let's try to find it here on the board. So we know that the right side of the MOSFET, where we have the missing pad, should be the drain, and the drain is directly connected with the R124, and to find it on the other side, here's a little hole. Don't know if you can see it, and I try to take a piece of wire and push it through, and now we gonna flip the board over, and yeah, here's now our wire which we have pushed through, and you see here now a little resistor, and of course another resistor. And yeah, when I now look onto my board, let me see, can we see it here? Yeah, I have already marked it, because the hole which we are using is from this pad, and it has a direct connection to the R124 and the 126, right? And back to our board, and the wire which we have pushed through, we see here our both resistors, which are connected directly to the what did we say? Drain, to the drain of of our transistor. And the same we need to do with the other side. And now you see there is a big capacitor in the way, because the missing hole is under this capacitor. But anyway, when I flip it over, I can see another hole. So the hole we did before was this down there, and here this is the other hole, which let me see, it is a little bit difficult with the camera in between, but you see I can push it in here. And more interesting is it still in focus? We are so close. Anyway, so this is now the gate side, and yeah, the gate should be connected to the C125, and should be connected to the C121 and the R121. And well, if we look a little bit more in detail, and I know all is very, very small. Yeah, so this little component down here is the C121, and this little capacitor is the C125, and this here is the R121. So we have all the resistors up here. So yeah, from this point of view, I hope that we only have two layers. So for the moment in time, it looks like this. And well, so that means when I flip it back over, so that means when I have a new transistor, which I need to order, I do not have it on stock. You can't really have anything on stock. That is really impossible. So that means that, okay, we have still our pad in the middle, and then we would solder the new component in, and then we would push again a piece of wires through the PCB, and would solder it on this side with the component, and on the other side we would solder the, yeah, you can see here are, so these are the holes, and I would clean it so we have the clear copper here on this side, and then I would solder it down here, and then we have the connections we need. And if nothing else is dyed around, then yeah, normally the circuit should work again. I mean, we do not finally know why the MOSFET has failed, so that is something maybe we will never find, but I will investigate the board a little more in depth, maybe that I can find something around, I don't know. And the next I have to do is to check the resistors, of if all the resistors have the given values, so that is very important. And then we have still another issue where we have to deal with, because yeah, let me take this schematic, and yeah, so you see this is our transistor to replace, but you see from this line here we get our power supply for the pre-driver and as well for this MOSFET as well. And yeah, you know, if this transistor has burned out as it is, then you know we will have a huge current going through these coils, and we need to check if these coils are still okay, because if not, you know, we have to replace these coils as well, and especially this guy here, and yeah, of course this as well could be damaged. So we really need to check these coils if they are still okay. Okay, and what we see else right now is that the L121 and L123, I believe, are missing. So this both coils should be here in the signal path. So that is when we have a look here into the schematic. So the supply voltage comes over these coils, and what we see that this both coils has been cut off. So that means they have obviously burned as well. So what we definitely need are two new coils and the MOSFET, and maybe with then the right connection through the board, maybe that this radio will work again. Yeah, so I know that this, where is it? Let me see. I know that this coil here is okay, so I have checked it out. This is okay, and this resistor, the 470 ohm resistor, is okay, but this both coils are missing completely, so yeah, obviously burnt out. So yeah, we order these new parts, and meanwhile I gonna clean the board as good I can on both sides, of course, and yeah, then when we have the new parts, hopefully we then have the radio back working. But well, there can be some additional faults which are not really obvious right now, but well, in any way there is no other way, so we have to proceed like this. Okay, I've taken off the capacitor right here from this place here, due to the fact that I need a little bit more space to bring in the new transistor, and well, then we have a problem here with the layer, because yeah, I think it is a bit difficult to see it here on the screen, but the layer is loose, as you can see. So yeah, I think you can see it. So this is what the heat done to the copper, to this pad, and well, I need therefore a bit more space first to bring in the new transistor, and secondly to fix it here a little bit with some glue. And well, then I have also a better access to this hole here, because as I have said it before, we need this hole and this hole to make contact through the PCB, just to connect at least the transistor to the right points in the circuit. So therefore it really was a good idea to take it away, and now we can much better work on this in this area here. Alright, the new parts are arrived from ICOM, so we can start replacing all the parts we need to replace. Alright, so I have here the new transistor, which needs to fit in here. So that is how it should looks like. So yeah, as I already said before, we only have one pin which we can directly solder on the rest of our PCB, on the rest of our copper pad, and well, then we can solder it up here to the copper as well, and that's it. But anyway, it is enough. It should be enough to fix it at least. And yeah, when it is fixed and the solder is holding it in place, then I can connect my wires through these both holes to get the connection to the other side of the board. So yeah, that is the plan right now. Hope that it will work. Okay, so what you can see here so far is that our transistor is now fixed and soldered in. So we need now to connect the other wires, and yeah, that is definitely the next step to do. Alright, so the next step is done. As you can see here and there. So this is now our connection through the board, and the wire is connected to these components here. So that is, I hope, a solid connection. And on the other side of the board, you can see that we have the wires still to be soldered. But yeah, you can clearly see how I have now done the connections, and now I will also connect these wires to the little transistor, and then we hope that all the connections are already back as they should. Soldering is done, as you can see down here. Very important is that you always have enough flux, because otherwise these solder points are not really handleable. So yeah, use enough flux and then it will definitely work, so no doubt. Board is now ready for testing, so everything is back in, and board is cleaned on both sides, so everything is done. So let us bring it together in the housing and see if it will work. So let's clean the heatsink first. So let us take away the old grease, and then we put some new grease to it, and the same we will do on the board, so that it is all nice and clean, and then we put back our board into the radio. Alright, so what you can see here is the main the power amplifier board is back in place, so everything is installed. And what we gonna do right now is, so if you go down here, you can see where we replaced our little transistor. And what we're gonna do right now is putting some voltage to the board. And the important thing is that without switching the radio on, we will already have voltage at our power amplifier transistors or on our preamplifier, and of course, and not of course as well, on our pre-driver. So therefore we are cranking now up the voltage very slowly and see if there is still somewhere a short, and well, then if there is no problem with cranking up the voltage, if there is no problem, then we can try to switch the radio on. Yeah, as I said before, I will monitor the voltage down here at our new transistor to be sure that really nothing happening to the circuit. And if there is no magic smoke until we have cranked it up to 13.8 volt and everything is nice and quiet and nothing gets hot, then well, yeah, then we can really try to switch the radio on. So what you're gonna see right now, this will be now our power supply, which will crank up, and this here will be the voltage at our transistor that we can monitor our transistor. And yeah, let us see if we can really crank the power supply up without having any problems. Yeah, and you see already 2 volt on the power supply and a little less at our transistors, so that is clear, because there are some little inductance and some little little resistors in between. So this little difference is okay. And now I'm just testing the temperature with my finger, and still very cold. So let us go up and see if it is still okay. So no problem up to now. And you see, this is also very important, because what we do not want to see is a high current which might be drawn, because then we know something is wrong. So it is not only the voltage levels we are checking out, it is also having an eye on our amp meter. But up to now, no problem. And yeah, once again, radio is not switched on, but our transistors are getting already voltages without having switched anything on. So that is the voltage which gets supplied into the radio, and all the transistors will already get power or voltage, whatever you want to call it. So let us go up. Let me check in between the temperature. No, it's good. And so this is 20 milliamps, so that might be okay. Yeah, 20 milliamps still. But you see, the voltage at our new transistor is exactly what we are supplying into the radio, so that is okay. And okay, so let us go up to 13.8. So that is now 13.8 at our transistor. That is okay, and we have no significant power drone, so that looks all fairly good. So the transistor is still cold, so no problem whatsoever. So up to here, this is really a good sign. Okay, so yeah, I've taken away the probe, which is here, so that's the reason why we do not see anything right now on this meter. So for me, this is a very good starting basis. So well, next will be to switch it on and see what happens. Yeah, let me place the camera a little bit different so that we can see the display. The speaker is attached already, and still we are supplying our 13.8 volt to the radio. And now the first big moment, or maybe already the second, because we haven't seen magic smoke while we were cranking up the voltage, so that was maybe our first good moment. And now I hope we will have a second, because now I want to switch the radio on, and yeah, normally it should really fire up, and well, we should see display. And okay, let's see what happens. Hey, so very nice. So we hear static, which is good from the speaker, and we see the display. Let me turn it down. So we have a display which is really nice, and let me check if we can change. Yeah, obviously we are able to change our bands, which is really good. And well, radio is drawing. Yeah, you can see it up there, 1.3 amps. So that is in receive, so no problem whatsoever. So that is okay. Yeah, now, you know, next step will be to connect our dummy load to the radio, and of course our power supply, our power meter, to see if we have or get output power. So okay, radio is now connected to the dummy load, and everything is prepared to do our first power check after repair. And well, so that is what we want to do right now. So let me reposition the camera so that you are able to see our watt meter. Alright, so let us check what we can see. So it is in, have a look, it is on upper sideband, and I'm talking into the microphone, and you see on the fast attack mode on our LP100, you see, yeah, 20 watt approximately. So that means we are reaching not full 100 watt. So let us check if, well, if there is something, if there is a wrong setting concerning our output power. Okay, so back to our display and our setting. So we should be able to change to yeah, RF power. and it is on position 3. That means that is not our full output. So let me see if I can crank it up until high. So that should be our full RF power, and we want to see if that is good. Yeah, back to our power meter, and let's see what the output power will be right now. Hola, audio. 1 2 1 2 3 1 2 3. So in fast attack mode it is 97 as far as I have seen it. So let's see what we can see with peak hold. 1 2 1 2. Hola, audio, audio. So it is 96 watt. Hola, hola. 1 2 3. Hola. So that looks good to me. So 96 watt is the peak, and yeah, that looks great. So that is basically good news. We know that our transmitter is working again, and well, we can't leave it as it is, so we should check the transmitter alignments, so that really everything is in good order. So therefore, next will be we following our service manual and performing some TX alignments. Well, a little view into the service manual. So what you can see here is the transmitter adjustments, and we will follow along, and you see it all starts with transmit total gain, output power and the force. So that is what we're gonna perform right now, and see if we can twiggle it here and there a little bit to improve it, that the transmitter is working in required order. Okay, so the requirement is putting the transceiver on 14.100 megahertz, and it should be switched to upper sideband, what it is, and the output, the adjusted output power here at our transceiver should be on high, so that means full power. So that is what what I've already adjusted, and well, now we have to connect our audio signal generator to the input, and then we're gonna start to twiggle some coils. So you find here the audio generator set to the requested values. So we have to set it on 1.5 kilohertz audio frequency with 3 millivolt RMS output. So that is what we have done, and we have connected our watt meter to the output of our radio, and well, down there, let me see, there is our test connection. So that is normally the microphone input, and I have here a switch which is replacing the PTT, and here I'm feeding in our audio signal. And now the manual is requesting to adjust this coils, no, not this, sorry, this coils down here, and this little pot down there, and this coils should be adjusted until we have the maximum RF power on our watt meter. And because we have the audio input level very low, the transmitter will not completely drive to the limit. Okay, so I just gonna switch now into transmit. Now it is in transmit, and we have our .3 volt RMS at the IF input, and yeah, we have 49 watt, and you see it is decreasing a little bit, so that is due to the increasing temperature. So therefore yeah, we need to wait a little bit until the whole system has been warmed up a little bit to hold it stable, more or less. And yeah, then let me start trying to improve the output, and that is what I'm already doing. So that is at least you see it is going up and down. Here we can, as you see, increase it a little bit, so it seems that 45, yeah, 45 seems to be the value which is okay. And with the next one we cannot really exceed 45, so 45.3, and the next one, so you see we are more or less at the limit. So that is, as you can see, the maximum I can achieve right here. So yeah, you know, this is not easy to perform, because you need to go back and forth and back and forth, and you always try to improve here and there a little bit, and yeah, therefore this procedure normally takes a bit longer. Now we have nearly our temperature, so our working temperature seems to be on a good level. So we are here on whatever, 44 watt, and I'm adjusting still. I'm still adjusting down here, so let me see if I can show it. Yeah, down there. So I'm adjusting here and there. So that is what I'm doing. And yeah, I need to go back and forth and back and forth, and well, this, as I already said, takes a while. Okay, so I've done the adjustments. So as I already said, it has taken a little while to go forth and back and forth and back. So that is always the same procedure. You do not really find the peak with your first walk, so you need to take another walk, and maybe again and again and back and forth, as I already said. So you have to be patient to get it all in order. So now I have finished it, and when I now switch to transmit, yeah, you can see we are now transmitting 100 watt. Now the radio is getting a bit warmer, and so the output level is dropping a little bit, and that is exactly what we want to see. And yeah, that means, so let me switch it back, so you see it is now nice and constant and stable. So that is exactly what we want. I now switch it back, and yeah, so that means our alignment procedure is done, and the transmitter is working again as we want to have it, and as of course the requirements of ICOM are. And yeah, that means we have finished this step here. Well, basically we are really at the end of this repair. So there are only some little jobs to do. So for instance, we have to put back this shielding here, which comes here over our driver section, and well, this down here is the VHF and UFH amplifier, and well, there is another shielding which comes in here. So that is what I have to finalize right now. But well, basically our repair is done, and this would only mean another video time, and it is not so exciting, so that I can say we really can stop here. So I put back the shielding, and then I put back all the wires, so which is also very easy to finalize, so nothing special at all. I put the housing over it, and then the radio can go back to the owner. So that's it, and I hope it was a little bit interesting for you. So that was a little bit delicate here and there. You have seen that a damaged transistor can really destroy your PCB, and yeah, that is really hurting, because you need to clean it and cut it out. And well, you have seen what it meant to do such a repair, and I'm sure that a lot of workshops won't do it, because it is always a risk, because you never can be sure that this repair is lasting forever, because you never know where there is maybe another connection which has been infected and could fail after a little while. So that is always a risk, but I think it is always worth to try it, and so we did. Okay, so let me close this video right here. I hope you enjoyed it, and well, catch you next time, and if you like it, please give me a big thumb up for this video. Bye!